Connecting sensors to an interface kit Phidget. There are a variety of sensors that you can use to gather input from the environment. We have available light sensors that measure the light intensity and will give values in the range of 0 to 0.99. Touch sensors that will detect if you touch the sensor. Rotation sensor, you can turn the knob around 300 degrees. Force sensors, and you press the button on the force sensor. Mini joystick. So the mini joystick has two connections, one for X and one for Y. Each return a value from 0 to 0.99. And then you have a slider that you can move from left to right. Those are a few of the sensors that we have available for you to check out. Now let's see, how do you connect it? You'll have an interface kit Phidget, and you'll plug your sensor directly into one of the different slots that's there, one of the black analog input slots. There are other devices here. You can have, let's see, 3 is for input, so you can have other digital input coming in, and then 4 is for output, like you can have LEDs and so forth being displayed or being lit when something occurs. And you plug this into the USB port of your computer. Now there are LCD Phidget text LCDs that are available that have the sensors that allow you to connect analog sensors to on one side, and the other side is a LCD screen. In this example here, I'm showing you that I've connected a slider to the LCD, a Phidget text LCD, and also you see that I can have text on that. Now, the voltage ratio input class is used for measuring the ratio between the voltage supplied to and the voltage returned from an attached sensor. It returns a value between 0 and 0.99. So let's just demonstrate this, connecting the sensors. Okay, in this demonstration, I'm showing you that I'm using an interface kit Phidget, and I'm connecting to several different sensors. The first one is a touch sensor. The next one is a rotation sensor. And then the third one here is a position light sensor. And I've connected them into different ports. So in port 1 is a touch sensor. Then port 3 is the rotation sensor. And port 5 is the light sensor. And these are connected here, and the interface kit Phidget is connected to a USB port. And then I have another motor here that's connected to another USB port. On the screen here in Phidget control panel, it shows you I have the interface kit Phidget and the servo motor connected. Okay, and you'll be seeing that I'll make changes in the interface kit Phidget in the different ones, and you'll see as I change the sensor, change the rotation, etc., you'll see the different values go from 0 to 999, or different values of touch. It's going to be 0 or 0.999. 0 to 1 are the values. Thanks. Alright, I showed you that you can use the control panel here, and then you can see the Phidgets that are attached here. You can also find the serial number. You would click on each of the Phidgets, and then you can find out a little bit more information. Let's see. Okay, so if you look at the Phidget interface kit, you double click on it and you'll see there's space for digital inputs, digital outputs, and you'll use the one that says voltage ratio input. I'll look at the rotation sensor, which is at number 3, and you'll notice when I change the value, I'm turning the knob. You see, I'll turn it one way, it's 0.099, and then I go all the way to the other side, and it's 0. So you see, depending on the value of the position of the rotation sensor, that knob, is changing the values. I can look at sensor number 1, which is my touch sensor, and when it's not touched now, on this model it's not touched, it is 0.99. You see it fluctuates, and then I touch it and you see how it goes to 0. So without touching it is 0.99, and it varies. You see the voltage changing a little bit. It's not touched, and then when I touch it, it changes to 0. Some versions have it the opposite way. You got to think about which, you got to test which sensor you're having. And the last one was a light sensor, and the light sensor is on line number channel number 5. And so when it's dark, I'm covering it up, it's 0, and then I've released it, and you see it's 0.11 something. It depends on how bright the light is. Those are the different values that are coming in. And then you can see there's a value for changing trigger here, and there won't be as many, it won't only register it'll only register the changes after so many. So I'll come over here after a certain value. I'll come over here to change trigger, and now when I cover it up, well, it requires a change of 0.2 voltage before it changes, so it didn't change with this one. Let me go and look at the number 3 again. Okay, and I changed the trigger on this one to 0.5. And so right now, as I'm turning it, it's see, it's changing a little bit differently here. But I'll come over here and I want it to change to 0.2. So it goes 0.02, then the next one is 0.27, 25, 7, and that's as high as it would go with that one. Then it comes down, and 5, 2, 0. So it's only changing them a different way. Okay? Let's stop. Alright, so you connect your Phidgets. You need to make sure you download the Phidget22.jar file. I have a link there that you can use that connects you directly to that library. And you'll make sure that you'll have that same stored in the same folder as your Phidget files. And then in JGrasp, you'll set the class path to include the Phidget22.jar for your workspace. Include the statement, import com.phidget22.jar, phidget22.asterisk there. One of the SIs has given you instructions and a video on how to set the class path using JGrasp. Now, programming in Java, you'll create a voltage ratio input object for each input sensor. Set the serial number for the interface Phidget. Set the channel as the port where the sensor is connected. Open the sensor. Wait 5 seconds for attachment. You can then set the change trigger, as I just demonstrated. This is how much the sensor value is changed before a change event occurs. And you can listen to the changes in the sensor by adding a voltage ratio change listener that implements the voltage ratio change method. I provided an example code for you that's here. This is showing you that I've created an object of sensor rotate, which is a voltage ratio input, and I demonstrate calling the method set device serial number, set channel, open, set voltage ratio change trigger, and then adding a voltage ratio change listener. Now, in this example here, the method on voltage ratio change is in the same program, so that's why I have this there. I'll give you an example of that. You should also explore the Phidget22 documentation and find out other methods that are available. So I'm just going to select this. Let's see, I press escape. And I'll just go back. And I will come here, view the API. And you see that I can go to Java and then go to voltage ratio input. And I can find out about the different methods that are there. You can find out about the different sensors that's needed. It lets me know what the name of the methods and objects I need to have. Okay, I can look that up. I can also look up one for LCD or RFID API. I can look at the methods that I have here for RFID. I can have one for LCD if you wanted to have your text appear in the LCD. That's how you would do that. Okay. There are sample code that's available there, and you can go and look at the sample code. So you can go to support software Java examples. So I'll come over here and I'll look at support software, and then I'll go down to the language Java. And it shows you there are several examples that you can have here. So if you go to Java examples, you'll see that there are some files that you can download. So if you want to have a program that deals with a voltage ratio input example, you can just choose download, and it'll show you, it'll download a file for you that you can experiment with. There are other sensors that you can search. Just search Phidget.com for analog input. We don't have any of the vent Phidgets yet. We don't have any of the new components. So I'm going to look for the ones that are similar to the ones we have in checkout, available on a checkout. Thank you.